Okay, welcome to the lesson on probability and odds. I'm going to go ahead and talk to you about some introductory information about probability, give you a general idea of what probability is all about. And let's go ahead and start out with some general information here about what probability is all about. Probability is a number between 0 and 1. It's a ratio, it's a fraction for the most part. It tells you how likely or unlikely something is to happen. Probability can have two different approaches. You can look at it in two different ways. You have experimental probability, which we'll discuss, and theoretical probability. They sound like fancy schmancy terms and kind of difficult sounding names are experimental and theoretical, but they're pretty simple ideas for the most part. I'll get to explain that later. Here's a kind of a number line here, so to speak, of probability and where all probabilities kind of fall between. And right here we have P of 0, which means the probability is 0. It's not going to occur. And then a probability of 1 means that it is certain to occur. It's 100%. This means 0%, and this means 100%. It's absolutely certain. But for the most part, you know, we're going to be dealing with probabilities that fall within this range right here. It's kind of difficult to say that something will happen for certain, 100% likelihood. I think we all can be pretty confident and say, yeah, the sun will come up tomorrow, or I am going to wear shoes on my feet when I go out for a run. But those are things that you can be confident about, but you can't really say with 100% confidence that it will definitely happen. We don't know. You know, today might be the last day we ever see the sun. You know, we could be covered by clouds for the rest of our waking life. We have no idea. Likewise can be said about um, things that are impossible. It's very difficult for us to say that something is impossible. But we're getting a little bit philosophical here. But like I said, most things occur between this range. That's where everything happens. You know, 50% occurs half the time. 25% or 2500ths, that's kind of an unlikely event. Or 7500, 75%, which is more in the likely range. Okay, let's go over some key ideas here, some key words. Outcome is defined as the possible results of an experiment. Here's an example. For instance, a die has 6 possible outcomes. A coin has 2 possible outcomes, heads or tails. Picking a letter of the alphabet has 26 outcomes. So that's a very general way of giving the possible results of an experiment. An event is an outcome or a collection of outcomes. Kind of, it's very similar to an outcome. Like, what's the difference? But let's go through this. An event, an example of an event, is when you roll the dice, roll the die. Some people are asking me, why did you write die? Well, die is the singular word for dice. Dice is when you have more than one. So you roll a die and you get a 5. Or you flip a coin and you get a tails. That's the event. The event is you got a 5. The event is you flipped a tails. That's what it is. Favorable outcomes are, that's an event that you have chosen, something that you need. Someone hasn't flipped a coin yet, and you're like, hey, I want a heads. That's the favorable outcome. The event that you have chosen. The favorable outcomes for picking a vowel are going to be A, E, I, O, and U. So if you're picking letters of the alphabet, you're going to want those letters. Those are your favorable outcomes. So let's go ahead and talk briefly about experimental versus theoretical. Experimental probability is when you take the number of successes and put it over the number of trials. So number of successes over the number of trials. Experimental probability is almost literally defined in its name. It's basically, it depends on the experiment that you do. You flip the coin and you flip it 10 times and maybe you get 8 heads out of 10, which is pretty good odds there. Well, that's not likely to happen, but that's incredible. You got 8 out of 10 heads. So you would put 8 on top, number of successes, and number of trials would be 10. So 8/10 reduces to 4/5. Okay. Theoretical probability, very similar to experimental probability, but this is based on the number of favorable outcomes over number of possible outcomes. So theoretical probability is going to be, you flip a coin and you say, well, I want a heads or a tails. Well, you can only pick one, so it's going to be 1. And how many possible outcomes are there on a coin? 2. So that's how that works out. That's what should happen. You should get a heads or a tails half the time. Doesn't always happen because of something called experimental probability. The coin does not have a mind. It does not think. Let's go on to the next one here. Now let's talk about how we can tell the difference between experimental and theoretical. Experimental is, you tossed a coin 10 times and recorded heads 3 times and tails 7 times. So those are your experimental probabilities right there. And theoretical is you toss a coin and getting a heads or tails is 1/2. This is in theory what should happen. Hence the name theoretical. This is in theory. In theory, we should spin a spinner that has 6 sides on it, 6 sections, and we should get that section 1 out of 6 times. That's in theory. That's what should happen. Experimental probability is what could happen. It depends on the experiment. All right, when you flip a coin, it does not remember what it was last time. It doesn't say, hey, I was heads last time. You better flip me next time and make sure I'm a tails. Or it doesn't say, hey, you flipped me already 100 times or almost 100 times, and I have a little bit too many heads. You better make sure you add some more tails so that it comes out 50 out of 100. It does not know that. Your coin does not think. It does not, think in those terms. It's an inanimate object. It does not think that way, hopefully. Experimental probability is found by repeating an experiment and observing the outcomes. Just like I was saying, you look at what happens from the results. It's experimental. It's based on evidence that you have done yourself. It's a very compelling type of probability based on how many trials you have used. The more you use, the better your experimental probability will match up with theoretical probability. If you just toss a coin 4 or 5 times, that's probably not a good indicator of what you really could get. If you toss a coin 500 times or 1,000 times or 10,000 times, you're going to get pretty close to what you should get in theory. You should get around 50%. And this is something I just talked about this. So this is in theory what should happen. You should get heads half the time. You should get tails the other half of the time. I don't always like to say that flipping a coin is 50-50. 50-50 actually equals 1. So it's not 100%. I think what people mean when they say 50-50 is they mean it's 50%. All right, I'm going to skip through this. Here's something else here. Theoretical probability is what should happen, and experimental probability is what could happen. Those are the ways that I like to explain the difference between those two. Theoretical is what should happen. You should pick a letter of the alphabet, and you should get the letter you want 1 out of 26 times. Experimentally, you could pick letters of the alphabet and correctly choose the right one 6 times in a row. That would be very lucky. Probably wouldn't happen. It's very unlikely for that to happen, but that's what could happen. Or you could pick 26 letters out of the alphabet, and of those 26, you could have picked none of them correctly. You could have made a wrong guess 26 times in a row. That could happen. The letters are not thinking, hey, he's on number 25. Let's make sure this next one works. It does, probability does not work that way. So in theory, you should pick the right letter 1 out of 26 times. Experimentally, For all I know, you could pick the right letter 2, 3, 4 times, or even none. Who knows? But that's the difference there. Here's some examples. Example 1. If you roll a number cube, a die, what is the probability that you will roll either a 4 or a 5? So rolling a 4 or 5. For example 2, of the first 70 students that entered Hubble's cafeteria, 18 agreed to take part in the survey about the delicious school lunches. What is the experimental probability that a student will take part in the survey? So go ahead and pause the video now and try these out on your own. Try not to go ahead. Really try to do these on your own and unpause the video and see what you got. Okay? All right, so here is example 1. So I have right here, just so you guys get used to the terminology that's being used, P stands for probability. So the probability or the chance of a 4 or a 5. So how many numbers are a 4 or a 5 on a die? Well, only 2. So you're going to use this ratio to help you solve this. Number of favorable outcomes over the number of possible outcomes. Well, how many numbers are 4 and 5? 2. How many numbers are there on a die? 6. And then what should you do to 2 over 6? You should, yes, you should reduce it. 2 to 6 reduces to 1 to 3. So your chances of picking a 4 or a 5 or rolling a 4 or 5 is 1 out of 3. That's how that works. Example 2, let's go on to this one. This is an experimental probability question, and you're going to basically do the same thing. So of the first 70 students that entered Hubble's cafeteria, 18 agreed to take part in the survey about the school lunch. So number of successes, what number would that be? Would that be 70 or would that be 18? Well, number of successes would be how many people successfully took the survey. Think of it that way. Was it 70? 70 people came into the lunchroom, but did they all take part in the survey? I don't think so. So it's got to be 18. 18 took part in the survey. What's the total number of outcomes? Well, you had 70 people. I know there's more than 70 people in our cafeteria at a given time, but we're just talking about the first 70. So it's going to be 18 out of 70. And then, of course, reduce that into simplest form. And what does 18 and 70 divide by? I think it's 2. So 18 divided by 2 is 9. And then 70 divided by 2 is 35. So to put that into like real terms, that basically means 9 out of 35 people will take part in that survey. Maybe I could do the same exact survey next week. I bet you if I did the same exact survey or same kind of thing, I would expect 9 out of 35 people to take part in that survey. And then I can use equivalent fractions to help me figure out some more, like 18 out of 70. I can do 27 out of 105. So those are all equivalent ratios. Those all equal each other. And I can keep going. You know, I could put zeros on there. I can multiply by 10. You know, 90 out of 350. You know, I would expect that number of people to take part in the survey. That's just how that goes. Okay, so that does it for probability. Make sure you guys fill out your flip notes and come ready with any questions or anything you're confused about tomorrow to class. Have a good night, everybody. See you tomorrow.